All right, here we go, more data. So 12.1, probability. I can describe the likelihood of an event. So probability is used to see how likely something's going to happen. Okay, it's kind of like how weather, right? They predict the weather. They take a lot of data and then use it to find the probability that it's going to happen. 30%, 20%, 90%. So it's always a number 0 to 1. So that's why it's kind of done in a percentage or decimals. It describes how likely an event will occur. It's supposed to say an event, not and event. All right, so I'm going to fix that so it says an event. Oh, there we go. All right, so an event is an outcome or set of outcomes of an experiment or a situation. So it's what you're getting out of it, right? So raining, or the next time you shoot the basketball, are you going to make it or not? The event is shooting the basketball, right? Making the basket. Hitting a baseball, right? There's probabilities and, their batting averages. So, how likely are they going to hit the next ball? The event is hitting that ball. So a trial is each repetition or observation of the experiment. So the way they get those data is they watch the baseball player hit the ball over the season, and then they get the batting average, and then they use that to decide if they're how likely are they going to hit the next one. So the trials are all the times the batter was up to bat. The outcome is what happened, the possible results. Did they hit it? Did they not hit it? First base, second base, how hard did they hit it? Was it a home run? Was it a single base, second base? Was it a fastball? There's lots of it, but the outcome is what actually happened. Okay, experiment, an activity based on chance. So pretty much anything we do, an experiment, is based on chance. We don't know what's really going to happen. So flipping a coin, drawing colors, markers or something out of a hat or basket. You don't know what color you're going to get. Even randomly pulling, if you have colored socks, randomly pulling the socks out of the drawer without looking. That's the experiment. It's something that might happen. A sample space is all the possible outcomes of the experiment. So for like a coin, its sample space is heads or tails. For hitting the baseball, it's hitting it or not. For drawing socks out of a drawer, let's say you have gray, black, white, and blue socks, that's your sample space, the colors of the socks. And then the last thing we have is a complement. A complement of an event is all the outcomes in the sample space that are not the event. So if I'm trying to figure out, how likely is it that I'll pull blue socks out of my drawer, the complement is how likely am I going to be not pull blue socks out of my drawer. Alrighty. So the top bar is how we look at likelihood. So we have 0%. It's impossible. It's not going to happen. So on a coin, actually let's do a dice. On a dice, there are 6 sides, 6 numbers, 1 through 6. The likelihood of me rolling an 8 is impossible. There isn't one. Okay, so that when it's impossible, meaning it's not even a part of my sample. Okay, we have unlikely. It just means it's not impossible, but it's very low percentage that it'll happen. Okay, that's like our 30s, our 20%, our 40% chance of rain, right? Now, as likely as not, and that's a confusing term, means 50-50. So 50% chance that it's going to happen. So a coin is a great example because there's a heads and a tails, 2 things. Only one can happen. 1 out of 2 is 50%. So it's meaning it's a 50-50 chance of it happening. Now likely is our higher percentages. So 60, 70, 80, 90% chance that it's going to happen. So when we talk about, the snow, they sometimes say that, and it happens. But the higher it is, the more likely it is. So that'd be like on a dice, I'm going to roll a number lower than 6. Well, that leaves 1, 2, 3, 4, and 5. That's 5 out of my 6 possibilities, so it's likely. And then certain means it's absolutely going to happen. I'm going to pull socks out of my sock drawer. Well, that's 100% likely going to happen, right? Well, we would hope so. Or I'm going to roll a number cube and I'm going to get a number larger than 0. Well, all the numbers on a number cube are larger than 0. So it is 100% likely to happen. So what we're going to do is, based off that, we're going to decide if these events, we have 3 of them down here, we're going to decide if they're impossible, not going to happen at all, unlikely, could happen, very low chance, likely is not, 50-50, likely, so high chance but not all the way, or certain, 100% possibility. And then based off that, we're going to say it's either a probability of 0, probability close to 0, that's our unlikely, probability a half, right, that's our 50-50, close to 1, that's our likely, or 1, that's our 100%. All right, let's do this. So you roll a 6-sided number cube, and the number is 1 or greater. So let's first list our possibilities, right? So the possibilities are 1, 2, 3, 4, 5, and 6, right? We want to roll a number is 1 or greater. 1 or greater. Well, 1 and all of these are greater. That's all my possibilities. 1 or greater. That's all of them. So we would call this certain and probability. Oh, forgot my R. Of 1, because it's 100% going to happen. All right, so you roll 2 number cubes, and the sum of the number is 3. Oh, we're going to add them. Okay, so let's think about it. If we do 1 plus 1, that gets me 2. 1 plus, oops, that's supposed to be a 1. 1 plus 2, that gets me 3. There's 1. Okay. Well, if I do 1 plus 3, that's too much. Right? That's already too much. How am I going to find all these? That's a lot. So let's do it this way.
Oh, I didn't know if you were like talking to someone.
No.
Oh, I heard you talking.
Say hi to Mr. Barrow, everybody. Okay, so let's do this in a little bit easier way, right? Like that's going to take forever. So, plus I have to know how many there are. So, let's kind of go like this. Let's think about this. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm going to kind of make a multiplication chart, but just with adding. Well, so we know this is 2. That's 3. That's 4. That's already too big, right? And then we know this is going to be 3. This is going to be 4. This is 4. It's way too big. I actually only have 2. I have 2. Look at how many I have left. Like there's going to be so many more. So is this really likely to happen? No. This is definitely unlikely. Let's put it in our box. Unlikely. Like 2 out of all of these that I would need to do. Unlikely. Not even 50-50. So we would say close to 0. It's not likely that we can roll 2 number cubes and get a sum that is 3. It is 3, right? I need it to be equal 3, not bigger than 3, equal to 3. There's only 2 of them. That's not likely. All right, a bowl contains discs marked with the numbers 1 through 10. That's a little easier. You close your eyes and select a disc at random. You pick an odd number. Okay, let's write our numbers down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, odd. 1, 3, 5, 7, 9. 1, 2, 3, 4, 5. How many are left? 1, 2, 3, 4, 5. 50, 50. So as likely as not, and then we just put a half. There it is. So it's nice when it's low, right? The first one we were able to list them, second one we were able to list them, but even the third one I was able to figure out, the second one was easy to figure out that there was no way it was going to be very high, right? So you can kind of do that quick check. Okay, so now we're going to actually full-blown find the probability, not just how close is it high, low, we're going to find it. So when we go to find the probability, it's a fraction because it has to be between 0 and 1, right? We always make it between 0 and 1, so it's going to be a fraction. The probability of whatever event I'm trying to find, so rolling a dice, picking socks out of a drawer, the last one was plates, that's my event. So we're going to do how many times it happens over how many total possibilities. Okay? So how many times it happens, could happen, and how many total possibilities I have. Okay? So the first one says, we're also going to find its complement. So how many times it cannot happen. So what is the probability of rolling an even number on a standard number cube? Standard meaning the 6-sided. I know there's number cubes that have 10 and 20 and whatever, but we're setting standard, so 6. So we look again at our cube. We have 1, 2, 3, 4, 5, 6. Okay? So our probability in our event is rolling an even number. There's 6 possibilities. That goes down here. I don't know why I wrote that so big. Let's make that smaller. 6 possibilities. See, 1, 2, 3, 4, 5, 6. Then even, there's 3 of them. So 3 out of 6, but we can always reduce and do half. Okay, so you just found the probability. What we're going to do is also find the complement. The complement, so we're going to go to the complement of not rolling an even number. So it's everything else. It's still out of 6. It's still same standard cube. Maybe I'll put little boxes around them. 1, 2, 3. All right, this is my circles. These are my boxes. Oh, I'm going to scoot that over. So there's still 3. So the complement, not rolling an even number, is still half. That's my little boxes. Okay, so the probability of rolling an even number is 3 out of 6, or half. And the probability of not rolling an even number, its complement, is 3 out of 6, or half. All right. So this one I'm going to start for you, and then I'm going to have you finish it. So it says, what is the probability of drawing a queen from a standard deck of cards? Okay, so again, probability, drawing a queen. Cards are very common when we're talking about probability. If you didn't know, there's a total of 52 cards in a deck. There's a silly game called 52 pickup. It's when you throw all the cards and make somebody else pick them all up. So 52 pickup, that's how I remember. So we're going to pull queens. So this is where maybe you pause, think about how many queens there are, and then I want you to make the fraction. And then I also want you to practice remembering to reduce it. So we need to also continue, this is a review, how do we reduce fractions? And then I want you to find the complement. Not drawing a queen. It's a really bad E. I'm going to fix that. There we go. Same thing out of 52. Okay, it's still out of 52. Okay, pause here, see if you can do this. And then if you don't, just play and see if you can figure out what happened, okay? All right, so there are 4 queens in a standard deck because there's 4 suits: clubs, spades, hearts, diamonds. So there's 4 queens in a standard deck. Now I need to reduce this, which means I'm going to divide it by 2, and then maybe I divide it again by 2, but that will get me 1 out of 13. So for every 13 cards, it's likely I will pull 1. That's not very high, right? That's what we would call unlikely, close to 0. Now, not drawing a queen is everything else. So 4 of them are queens. We would technically need to do 52, take away 4, right, to figure out what's not a queen. That's 48 of them. So this one's out of 48. And then again, we need to reduce. So you could divide by 2, then maybe 2 again. And we should say this is 12 out of 13. That's a lot higher now. So this is definitely would be likely that we would pull not a queen out of a deck of cards, right? Close to 1, which it is. 12 out of 13 is very close to 1. All right, so things to remember. So remember, probability is total possibilities over event possibilities. And another way you can think about it. Okay, so this is your independent practice. There's 2 questions. It even tells you that there are 4 aces and 4 kinds in a standard deck of cards. They're helping you out. You pick 1 card at random, and it says, what's the probability of selecting an ace or a king? Okay, so think about that. That's a little different. There's 2 of them. Probability of selecting an ace or a king. And what's its complement? So complement, not selecting an ace or a king. Remember, these are both going to be out of 52, just like our practice problem right before this. Alrighty, until next time.